All right, let's move on to the surface area of a revolution. And it's interesting because we've talked a lot about volumes of revolution, but we haven't thought about how much surface area is created when you take a function like this and you revolve it around an axis of revolution. You're going to get this whole surface area here. So that's what we're going to look at today or in this lesson. And basically what you want to do, instead of finding the area of each cross-section, you want the circumference of each cross-section. And you're going to add up all of the circumferences of all of the cross-sections, and you do that by integrating. So basically you're going to have an infinite number of circular cross-sections here, and you're going to take a look at each of the circumferences. So we know that circumference is 2 pi r. What we're going to have is r equal to f of x, and this is of course in the assumption that we're rotating around the x-axis. So this, for example, would be the radius, which is equal to f of x. So each circumference is going to be c equals 2 pi times f of x. Now, how wide will each circumference be? So a really standard guess is dx, but the problem is that's only going to hold true for a horizontal line. So the distance, a tiny little distance on the x-axis might be delta x, but a tiny little distance here isn't delta x because we've got a slope that's not zero. We've got, a change in the curve. It's not a horizontal line, so you can't just call it a change in an x value. So we've got to figure out a way to take this slice, for example, of the curve, and we're going to do that using the arc length formula, which you learned is 1 plus f prime of x all squared. Okay, so if we have each circular cross-section is going to have a circumference of 2 pi f of x and a width equal to the arc length formula. So 1 plus f prime of x all squared. Okay, so now what you're going to do by integration, you're going to add up all of these cross sections. So basically when you rotate a curve around the x-axis, you're going to integrate from a to b. You have a 2 pi out in front, and then you've got f of x times 1 plus f prime of x all squared, and we do need the dx in. This is a 1 plus right here, dx in, and we integrate from there.